It is necessary to talk about memory, the way variables are stored in memory, and the way memory is organized. So the first thing to say is that memory is what lives on a chip in your computer, and it is extremely small. It's comprised of transistors. Okay, these are some transistors here that are extremely big compared to what you would find in your memory. Okay. But basically, the computer memory has millions and millions of these, depending on how many bytes or gigabytes you have in your memory. Now, each of these transistors can store either charge or no charge, meaning a 1 or a 0. By now, I assume that you know that everything in a computer is stored as a 1 or a 0. Okay? Now, a group of 8 ones and zeros is called a byte. So, excuse me. So one could represent, for example, the organization of memory in a computer kind of like this, where you have bytes. Okay, the computer has bytes. If here there's like a little equivalence of things, so 1 byte is 8 bits or 8 transistors, and then 4 gigabytes, which is a common, a common memory for a computer now, would amount to 4,000 million bytes, which then in turn multiplied by 8, and then you get how many transistors are there in a computer, just in the RAM memory. Okay. Now, the rest is discussion for a computer architecture class, but in terms of Java, variables are going to be stored in this memory. So one way that people represent this memory is by doing it by bytes. So there's a lot of bytes, right? There's a lot of bytes in your memory, and actually this we will represent their addresses, or basically where they are located, okay, with hexadecimal numbers like this one, 12F, or like this one, which is like 8 Fs, right, to represent a 10-digit number. Now, the important part here is that the computer needs to know where to go to access memory. That's why each byte has an address, okay, that tells the computer where to go. So if I say address 12A, the computer will know to go and examine this set of 8 transistors, okay? So that is done by the computer. You don't care too much about that. All you need to know is that there is a collection of bytes, and they all have an address or a way to locate them. Let's go now to a Java program, and let's see what happens with variables and how it is how this is handled. The Java virtual machine, which is it's actually a program that looks at our Java source code, compiles it. Basically, it converts them into bytes and into some sort of code. When it interprets our program, it keeps a little table of where of what variables correspond to what memory address, and that memory address in turn will serve to see where in memory are the values for those variables located. For example, let's look at this little program here. It just assigns variables to things. So short A equals 500. First, the table puts the variable name A, and then the table looks up. A short is 2 bytes long. So let's say this short lives in memory 0. So what I'm going to do is I'm going to reserve memory 0 here, say red, memory address 0. It's going to be red. I'm going to reserve that. That happens when I say short A. Okay. Now I say equals 500. So I need to put 500 in binary. So I have a little thing here to help me convert things. 500 in binary is 1, 2, 3, 4, 5, 6, 7, 8, 9 bits. That means it's 1 byte, which is 8 bits, and then some, right? We usually start from right to left writing these things. And in that case, this will become 1, 2, 3, 4, 5, 6, 7, 8. That's the 1 there. This first 1 here. okay, the first one in here, and then the rest of the numbers, which are 11110100. And that says that A lives at memory address 0 because it's a short. It has 2 bytes, I'm sorry, and these are the contents of each bit of those 2 bytes, which in binary represent the number 500. So when you say short A equals 500, this is what happens. 500 gets converted to binary. A variable is declared in the memory table, in the variable table, that tells the computer in which address is this 500 store. At address 0. Okay, 0, and I know it's a short, so the next byte is also part of this. And it's read 00000001111110100. Alright, let's go to the next line. Int b equals 35. So b will be, say, at location, well, we'll look for a free location, right? So b can be at number 2, at address number 2, because that's free, right? And it has, the integer uses 4 bytes, and b, and address number 2 has 4 bytes free from then on. 1, 2, 3, 4. 4 consecutive free bytes. So b will be here. 4 bytes will be there, and then here we're going to store the integer 35. Now 35 in binary is 100011, so this is going to look like this. 100011. This is what this will look like. There's a lot of, if you will, lost space here, but that's because the integers allow you to put such large numbers that, you know, when you put 35, you're basically misutilizing or not using a lot of the bytes in there. Okay, and that's how we represent B. Now C, which is a double here. Let me look at the line. Double C. C is 3.4, and doubles, if you look at this table, doubles are 8 bytes in length. So where are 8 consecutive bytes? Well, perhaps at, say, 129, there is 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. There's also 8 at 121. I mean, in many locations, the Java virtual machine will pick one and will put the variable there, okay? So let's pick 129. So C will be at 129. They don't need to be consecutive, although it makes things more efficient. Let's say 129. That color, it's 8, so I know that that's 8 spaces or 8 bytes. And then the contents of 3.4, which let's say is this number. And then 110, I don't know, something like that. Okay, so this might be the representation, the binary representation for 3.5. And because it's 8 bytes, it knows it's double. So this table keeps a record of the variable names, where they start, and it also keeps a record of what kind of variable they are. So if A is a short, it knows that it starts at 0, and then it has that byte, and then the next byte, because it's 2 bytes. It knows that if C is a double and starts at 129, then there's 8 consecutive bytes starting from 129 that belong to C. Okay? And then car D is the letter H. Okay? Let's look for, and cars are 2 bytes long. You can see this here. So let's look for any two free bytes. So 122. 122 is open, and it's going to be, say, green, and then 122 here, right? So in memory, I'm going to store the letter H, which might be something like this. Something like that. I don't know. These binary codes are given by the number of the letter, and that can be found in the ASCII code tables. Okay, but this is basically how memory works. Java looks at the variable, at the type, and the contents. It looks at free space in the memory that can store that variable, and then the variable name gets a memory address assigned, and that gets put in, and the value of that gets put in memory. So if I ever want to then print A, what the machine's going to do is it's going to go and say, oh, A is at memory address 0. and it contains this, which turns out to be 500. So when you say print A, it goes, looks it up, brings the value, and then prints it. Okay, you want to print the character H, you say print D, for example, system.out.println D. What's going to happen, it's going to look here, D here. It's at memory address 122, and because it's a character, it's only 2 bytes. So it's going to go to memory address 122, get the 2 bytes from there, and then convert them into a letter and print it out. Okay, this is how memory basically works. We're going to see a simpler representation of this, and then how more complicated stuff can happen.